In this video, I'm going to do question number 15, a question based on differentiation. Over here, it is given that we are given x minus a whole square plus y minus b whole square is c square for some value of c, which is greater than 0. We need to prove that 1 plus square of dy by dx raised to the power 3 by 2 that divided by d square y by dx square is a constant independent of a and b. That means should be a constant, but not a and b. Like if I start differentiating the given expression, both sides with respect to x, so what we are going to get is differentiation of this is what? That is 2x minus a, and then plus differentiation of this will be 2y minus b, but for y, it's going to be dy by dx is equal to the differentiation of c being a constant should be 0. Now, if I isolate dy by dx by transposing the other numbers, so it's going to be minus 2 times x minus a, there's 2 here, minus 2 times x minus a, that divided by y minus b, 2 times y minus b. As you can see, 2 and 2 get cancelled here. So we are left with this. So I mark this as equation 1. Now we'll be finding the second order derivative here only. Differentiating this with respect to x again is going to be d square y by dx square. Here I'm going to apply the quotient rule. So the differentiation of numerator, that is u, is 1, say, and denominator, that is v, is this. Then we have a minus sign. Differentiation of denominator. So first I write the numerator as it is, and the differentiation of the denominator, that is dy by dx. So this is going to be dy by dx. And that divided by y minus b whole square. Now in the next step, what I'm going to do, I'm going to replace the dy by dx with its value. So we'll get this. And say we'll get here. This is d square y by dx square will be, I can see there is a minus 1 here. So it's minus y minus b. And I'm going to replace this dy by dx with its value. So there is a minus, and this minus will make it plus. So that's going to be plus x minus a, that multiplied by the value of dy by dx, which is x minus a over y minus b, and that whole divided by y minus b, the whole square. Continue with the further simplification. I can see there is a minus common. So if I take minus common here, and if I take LCM, clearly this y minus b will be multiplied with y minus b. So it's going to be y minus b whole square plus this 2 will multiply to give you x minus a whole square, and then divided by the LCM when multiplied by this is going to be y minus b the whole cube. Now what you can see here that I can replace this thing. I can replace x minus a plus y minus b, right? The square as with c square. So this is what I'm going to change here. I'm going to replace this with c. To replace this with c. So we have this as d square y by dx square is equal to minus, this is c square, and that divided by y minus b the whole cube. So this is the second order derivative we got. Now finally we are going to plug in these values on the to prove part where I'm going to replace this dy by dx and d square y by dx square. So we'll have this as 1 plus the square of dy by dx, right? The square of this will be positive x minus a squared over y minus b square. And then can see that it is with a whole power as 3 by 2 that divided by d square y by dx square, that is from equation 2. That means from here, I can write this as, this is minus c square over y minus b whole cube. Now what you can see here that if I take LCM, this will be multiplied with this. So I can see this will give you y minus b whole square plus x minus a square, and that divided by y minus b square, and then this whole power is 3 by 2. This when divided by minus c square by y minus b the whole cube. Now I'll need some space here. So you can see this is, once again, I'm going to replace this thing with, let me show you. This I can replace with c again. As you know that x square minus x minus a whole square plus y minus b whole square is c square. So if I replace this with c square, that divided by y minus b whole square, and then we have whole power 3 by 2. I missed one minus sign here. So minus was, there is a minus sign. So we missed when we took minus common. So there's a minus, we missed it. Oh, we didn't miss that minus sign. Minus sign, I can see we carried it and it's over here. Okay, so if I write this, that's divided by c square over y minus b whole cube. Now for further simplification, you can see that if I apply this power over there, this and this, including this, will get cancelled. So we'll get what? We'll get say minus outside. So this is c raised to the power 3 we'll get, and below we'll get y minus b raised to the power 3. Once again, if I apply this power over here, 2 and 2 get cancelled. So we'll get y minus b whole cube. And same with the numerator. When we apply this power, applying the laws of exponent, so this and this will get cancelled. So we'll get c raised to the power 3. Now, then dividing is same as multiplying with the reciprocal. So I can write this as y minus b whole cube, that divided by c square. Further, you can see that this is cancelled. And if I cancel this with this, so I'll get minus c as the final answer. Moreover, you can see that here the RH, this is what we are required to prove, that the answer for this part should be independent of A and B, and that is what we got, C, which is independent of A and B, and that's also a constant.